Telescopes caught it first, a flash, sudden and sharp, deep inside the massive green coma of 3I/TLAS. For a moment, data streams from survey observatories looked like glitches. Then, confirmations poured in. The brightness curve leapt upward in a single night. Something had happened inside the interstellar visitor. Speculation came instantly. Was this an ordinary outburst, the kind comets often display as sunlight cracks their icy crusts? Or had something struck the object itself, releasing a burst of dust and debris? NASA confirmed what the images suggested: an unusual plume radiating outward from near the nucleus, uneven, tilted, unlike the smooth halos seen before. Atlas had changed shape, and the world was watching. The possibilities spread quickly. Some scientists pointed to the relentless heat of the sun as a TLAS swept inward. Volatiles locked inside the core may have burst through weak spots, spraying dust in unpredictable directions. Others wondered if an external body, a meteoroid, a fragment, or hidden debris, had collided with the comet. The evidence was incomplete, but the impact scenario could not be dismissed. The question echoed: had we just witnessed a cosmic collision in real time? Amateur astronomers added to the storm. From backyards in Arizona, deserts in Chile, and rooftops across Europe, observers compared notes. Light curves recorded the same sudden anomaly. The object was brighter than any projection, and the pattern did not match a simple gas flare. Something else was happening. The excitement was palpable. Forums filled with stacked images, animated GIFs, and urgent analyses. Images told their own story. Instead of a uniform coma expanding evenly, ATLAS now displayed jagged dust fans spraying out in uneven arcs. The geometry suggested directionality, not the smooth outgassing of frozen ices. For seasoned comet hunters, the signatures looked closer to ejecta from a physical disruption than to thermal cracks alone. It was as if the comet's skin had been torn open. Spectroscopy backed this impression. Instruments tracking the comet's emission lines detected abrupt spikes in carbon compounds, alongside surges in fine dust particles scattering light. The numbers were consistent with fresh material exposed suddenly, not the slow venting of long-standing jets. New surface had been laid bare, releasing gases unseen in prior weeks. The comet was bleeding data into every telescope aimed at it. Discussion spread across professional circles, but it was amateurs who kept the watch continuous. Every hour brought new measurements. Each faint uptick or asymmetry became fuel for debate. Was this the scar of a strike? Was the nucleus fracturing under stress? Or had hidden jets, buried deep in alien ice, ripped open to the vacuum in spectacular fashion? The interpretations diverged, but the mystery deepened. Within 36 hours, the scale became undeniable. Atlas's coma had ballooned to more than 800,000 kilometers wide, surpassing even Jupiter's diameter. The sheer expansion was staggering. The object looked less like a solitary comet and more like a drifting world-sized cloud. Brightness jumped by nearly a full magnitude in that short window. For astronomers, the numbers alone marked this as one of the most dramatic changes ever recorded in an interstellar body. Comparisons surfaced quickly. The last time scientists had seen such raw violence from beyond Earth was in 1994, when fragments of comet Shoemaker-Levy 9 slammed into Jupiter, leaving scars across the planet's atmosphere. That was a collision on a planetary stage, but it had been observed from afar. Now, in 2025, telescopes seem to be catching a similar drama focused on a cometary visitor never seen before. For Atlas, the context made it even more profound. This was not an ordinary long-period comet looping back after millennia. Its orbit was hyperbolic, a straight line through the solar system, never to return. Every image, every spectrum, every spike in brightness was a one-time opportunity. No second chances would come after it vanished into interstellar space again. That urgency drove the frenzy across both professional teams and backyard networks. The debris plume added urgency. If the event was indeed a collision, then it implied more than just surface scars. It suggested that ATLAS was traveling through a corridor of hidden objects, fragments, or debris streams. Each particle carried the potential for further strikes, each strike the chance to trigger more outbursts. Planetary defense groups took notice. A hyperbolic traveler shedding fragments could leave trails that Earth might one day cross. Data streamed from observatories across the globe. Pan-STARRS in Hawaii, the Rubin Observatory in Chile, Catalina in Arizona, all reported the same result. Atlas was not following the script of a standard brightening. Its curve was spiking erratically, its morphology shifting day to day. What began as a point of light had evolved into a stage for dynamic events no one had predicted. Even more intriguing were the asymmetries. The coma no longer appeared centered. Dust and gas stretched in uneven shapes, almost fan-like, as if material had been ejected in a directed spray. For some, this was the hallmark of a sudden impact, a smaller body punching into the surface at high velocity and carving out a jet. For others, it was simply the stress of internal heating ripping the surface in unpredictable bursts. Regardless of interpretation, the magnitude of change stunned the community. The size of the coma alone now rivaled the width of entire planets. The light it cast outshone projections by wide margins. To observers on Earth, ATLAS was not just another comet. It had become the most unpredictable, most dynamic interstellar visitor in recorded history. Theories multiplied. Was this the first time we had witnessed an interstellar body colliding with material inside our solar system? Could the event hint at unseen populations of dust or rocks traveling with ATLAS? Or was this a natural fracture, magnified by the comet's unique chemistry? Each hypothesis demanded evidence, and every telescope on Earth raced to supply it. In many ways, the mystery overshadowed the data itself. For the public, headlines about something slamming into ATLAS captured imaginations instantly. For scientists, the event represented a puzzle at the intersection of cometary physics, solar system dynamics, and planetary defense. In both cases, the flash inside that green halo had become more than a data point. It was a turning point in the story of an object already unlike any other. Mars had been in position for weeks, its orbit aligning to give a rare vantage point on the interstellar comet. When the flash tore through Atlas's coma, those orbiters instantly became humanity's only witnesses. Earth's telescopes were already retreating into twilight, their windows closing. The red planet carried the burden of watching what came next. MAVEN was the first to report. Its plasma detectors, designed to monitor Mars's upper atmosphere, began recording spikes out of pattern. Disturbances rolled through the solar wind, not gentle fluctuations, but sharp signatures that suggested material flung outward. The data hinted at ejecta moving in coherent waves, particles pushed into the current as if from an explosion. The ExoMars Trace Gas Orbiter turned its instruments on the expanding coma. Almost immediately, its sensors flagged new chemical spikes. Carbon compounds surged higher than before, and faint traces of exotic volatiles rose in the spectrometer lines. The pattern did not match the usual profile of a comet's steady heating. Instead, it spoke of fresh surfaces exposed all at once, releasing pockets of gases that had not seen starlight since ATLAS left its home system. The Mars Reconnaissance Orbiter attempted something bolder. Using its high-resolution HiRISE camera, engineers pushed the limits of tracking, hoping to isolate the faint dot of the nucleus buried in the glow. Processed images showed irregular shapes, patches of brightness, and shadows that suggested a scar. While confirmation would take weeks of refinement, the early frames looked like a wound carved across the surface of the interstellar traveler. Each orbiter added another piece. Plasma, gas, imagery, all converged into a single story of sudden violence. Mars had become a cosmic outpost, catching the aftermath that Earth could no longer see. For astronomers on the ground, the data carried a weight that could not be overstated. And if you're following these discoveries as closely as we are, make sure to hit that subscribe button and give this video a like so you never miss the next breakthrough. The reaction in scientific circles was immediate. One line of thought argued for collision. A small meteoroid, a fragment wandering the same corridor, could have struck ATLAS head-on. At 60 kilometers per second, even a body no larger than a car would unleash power equal to thousands of tons of TNT. The flash, the plume, the asymmetric fans of dust all matched the signature of an impact. Others insisted no external strike was needed. Comets are fragile, riddled with fractures, built from ices that turn volatile when warmed. The pressure inside a sealed pocket could rupture a surface crust, spraying debris and light into space. Atlas, with its runaway brightness and massive coma, was the ideal candidate for such an outburst. A natural fracture could explain everything without requiring a hidden projectile. But the debate carried consequences. If Atlas had been struck, it suggested that unseen debris might be accompanying it. Fragments from its own formation, or a shattered companion trailing close behind, could be following the same path. If Earth crossed even a thin stream of that debris, the implications for planetary defense would be profound. Models were run overnight. Orbital dynamics recalculated, simulations tested for intersections in the coming years. If the rupture theory held, the risks were different but no less dramatic. A nucleus that split once might split again. Each approach toward the sun could force another break, each break larger than the last. Instead of a single plume, there could be multiple outbursts, cascading into a series of violent surges as perihelion drew near. For astronomers, either explanation was extraordinary. A visible impact on an interstellar object or a structural collapse revealing alien chemistry, both would mark milestones in observation. Few could decide which was more significant. The evidence continued to pour in, each data set sparking another round of late-night analysis and hurried conference calls. Atlas itself did not wait. Its coma, already immense, swelled further in the wake of the event. Within a day and a half, the glowing envelope measured more than 800,000 kilometers across. Against that backdrop, Jupiter would vanish as a speck. Its brightness leapt by nearly a full magnitude, a surge captured in the curves plotted by amateur astronomers across the globe. The numbers climbed so sharply that comparisons were inevitable. Shoemaker-Levy 9, the comet that smashed into Jupiter in 1994, had left scars visible for months. Now, an interstellar comet was replaying that drama on a different stage. For professionals, the rarity of the moment was sobering. Atlas's hyperbolic trajectory guaranteed that there would be no second chances. This was not a visitor that would swing around the sun and return centuries later. It was a one-time encounter, a single crossing of the solar system before vanishing into the dark. To see it brighten, fracture, or collide was to witness a spectacle that would not repeat. Mars remained the silent witness. Its orbiters recorded plasma clouds, mapped chemical spikes, and strained to catch images of a nucleus that might now be changed forever. Each packet of data returned carried with it a reminder that this event was unfolding in real time, beyond Earth's ability to track. The red planet had become the eye of the solar system, holding its gaze on a traveler from the stars that had just revealed another layer of its mystery. The scientific world braced itself for what would come next. If the impact theory was right, more fragments might still lie ahead, waiting in the same trajectory. If rupture was the truth, ATLAS could erupt again as it rushed toward perihelion. Either path carried unknowns, and each unknown was loaded with significance. The comet had already broken records with its green glow, its vast coma, its unpredictable behavior. Now it had delivered a moment few thought possible, the chance to watch either a strike or a shattering in real time. The scale of the event guaranteed its place in history. Atlas had already defied classification, a body that refused to fit the patterns of its predecessors. Now it carried the distinction of being the first interstellar object to suffer visible violence under human observation. For researchers, it was nothing less than a natural experiment written across the sky. For everyone else, it was a reminder that the cosmos is not still but alive with encounters and collisions that reshape its visitors in an instant. And Atlas was still brightening. The coma continued to expand. The nucleus, scarred or fractured, drove onward on its hyperbolic path, closer each day to the sun. Scientists tracked, argued, recalculated, and prepared for the next phase. Whatever had just happened was only the beginning, and what came next could eclipse even this.